Okay, good afternoon.
Good afternoon, sir.
Good afternoon. So today we'll discuss the internal energy of steam. It may be water, it may be wet steam, it may be dry steam, or it may be superheated steam. So in the last class we discussed that internal latent heat only for the vaporization, HFG, latent heat of vaporization, is PVG. During this vaporization, this is the work done, and this beyond work done there is something this, and this part is called the internal latent heat that we discussed in the last class. So from this we can make one equation. What is that? That is the internal latent heat is equal to the latent heat of vaporization minus work done, and this is only during evaporation, because work is done only during evaporation. Although we add heat, work is not done. Only during evaporation work done begins, because during evaporation there is change in volume, but before that, up to the saturation, up to the boiling point, it remained as water. So if it remained as water, the volume VF, specific volume of saturated liquid, remain same. So that means no change in volume, therefore there is no work done. So this way we can say that total heat of steam is how much? We know sensible heat, that is HF, plus latent heat of vaporization, that is HFG, and this is the total heat H. So we can write like this, and from this we can also write, just now we have got PVG, that means HFG is what? PVG plus internal latent heat. So now if we rearrange this, then it will be what? We can write HF plus internal latent heat plus this much, and this fraction, this component is called the internal energy of steam. That is called internal energy. So this much HF, sensible heat, plus internal latent. So we can also write mathematically enthalpy, total enthalpy is equal to internal energy U plus PVG, and this equation you can recall from the previous classes. What is H? Enthalpy is equal to internal energy plus PV, and this is same. Only thing is this is steam, so we write PVG, volume, specific volume of dry steam. So how we can write? If we want to know what is internal energy of H minus total heat minus PVG. So this is for any steam. U is equal to enthalpy minus PVG. That is for any steam. So for dry steam, in place of U we can write UG. That means internal energy of dry steam is equal to enthalpy. What is the total enthalpy of dry steam? Hg, which is equal to HF plus HFG minus PVG. So this is the relation for dry steam, internal energy of dry steam. Okay, then what about the wet steam? So we'll use U, internal energy of wet steam, is equal to, definitely it will be the enthalpy of wet steam minus the work done. How much is the work done for wet steam? X, that is because this is wet steam, which X is the dryness fraction of steam, dF, dryness fraction of the wet steam, and PVG. Superheated steam. If the steam is superheated, the relation will be same. Internal energy of superheated steam is equal to enthalpy of superheated steam, which we already know what is the enthalpy of superheated steam, minus the work done by the superheated steam. And this will be like this. Enthalpy of superheated steam minus P into V sup, specific volume of superheated steam. What is V sup? Last class we discussed V sup divided by T sup, that means temperature of superheated steam, is equal to Vg. Salt's law, this is nothing but the Salt's law. So that is equal to T sup divided by Tg into Vg. From this we can find out the specific volume of superheated steam, internal energy. Now come to the entropy of steam. So entropy we discussed. What is the relation for entropy? Entropy is represented by S. So change in entropy is equal to heat interaction divided by temperature. That is the relation for entropy. Any gas, but we are talking about steam. So what is delta Q? Delta Q we know CPW, because what we are talking about production of steam at constant pressure. So that is why it is CPW dt. We know mCp dt, that is the amount of heat. So in place of m, that is equal to 1, Cp is CPW, specific heat of water, and dt, temperature difference, and delta Q divided by T, that is why divided by T. If we do the integration of this, then what we will get? This is the differential form. So if we do integration for a process, say we are talking about process 1, 2. So if we do integration, that will be from 1 to 2 ds is equal to integration from 1 to 2 CPW dt divided by T. So it will be S2 minus S1. That means change in entropy. That means we also simply ds also we can write. That is equal to CPW integration of dt divided by T. What is the integration? Yes, please. Log to the base E T. Now the limit is what? T2 from T1 to T2. CPW log to the base E T2 divided by T1. Generally, the entropy or enthalpy or internal energy, whatever be the thing, we measure it from 0 degree centigrade. Okay, that means if we measure it from 0 degree centigrade, then T1 is equal to what? T naught. We can write T naught because that temperature is T2 divided by T naught. Now what is T naught? 0 degree centigrade. Good. But we have to put this in Kelvin scale. So it will be T2, or simply we can write, say temperature is something like anything. Okay, it is T2 is okay. Divided by 0 degree centigrade. If since it is Kelvin, it will be 273. Because it is in Kelvin. 0 plus 273, that is, this is the relation for change in entropy of steam. Any steam, it may be wet steam, it may be dry steam, it may be superheated steam. If the steam we consider only the during evaporation, then what is the entropy? Only for evaporation, then entropy of evaporation is what? Entropy is always delta Q by T, change in entropy. So what is the change in entropy? Delta Q is what? Change in enthalpy or change in heat equal to HFG. And what is the temperature during evaporation? That is Ts. Okay, am I clear? entropy during evaporation we are talking about. So during evaporation, what is the heat interaction? That is equal to HFG. Entropy, or it is called the latent heat of evaporation, divided by temperature. In this case, temperature is not changing, so we need not do integration because temperature is fixed. And what is that temperature? That is equal to Ts, saturation temperature, boiling point of water in that particular pressure. Now come to entropy of wet steam. So first we find out for any steam, this is the relation. Then we find out for entropy of evaporation, during evaporation, and then entropy during of a wet steam. So we write S wet, that means entropy of wet steam is equal to SF. Now what is this SF? Entropy from 0 degrees centigrade to the boiling point. Water, entropy of water, that is why we write SF plus SFG. What is SFG? This is SFG. Entropy of evaporation is SFG. So multiplied by X, the dryness fraction. And again, what is SFG? Just now we have find out that this is equal to HFG divided by Ts. Now entropy of superheated steam, we will write SUP, soup. So definitely first we will consider the dry part, that means SG plus CPG, log of E, T soup divided by Ts. You look at this formula. What is this? CPW, because that was water, but this is superheated steam. So that is why we write CPG, superheated steam. Log of E to the higher temperature divided by lower temperature. Highest temperature is T soup divided by from which temperature it is increasing? From the saturation temperature, Ts. So that is about entropy of superheated steam. Okay. So till now what we have got in properties of steam, first we got in the 2 or 3 class before this enthalpy H, which we call the total enthalpy of steam. What is this? Total enthalpy. Then enthalpy of steam we can say for water. Water means below saturation temperature. For water at any temperature T1 degree centigrade. T1 degree centigrade means T1 is below Ts. So we will call H equal to what? mCp, temperature difference. Temperature is T1. We put it in T1 plus 273 minus from which temperature we are considering? From 0 degrees centigrade. And that is means this is 0 plus 273. And in fact these two will get cancelled, and what will remain after this? Simply mCp T1. But this T1 we have to consider this is not in Kelvin, because 273 is cancelled. This is T1 is what? Difference in temperature. And this m will be 1 for 1 kg of steam. And that means this is simply CpT1 that we have discussed earlier. What is enthalpy of water? Now for saturated water, what is a saturated water? Water at boiling point, but it is 100% water. Remember, it is 100% water, but the temperature is Ts, boiling point or saturation temperature. That enthalpy is equal to m. Definitely it will be 1 for specific enthalpy into Cp. We can write W also, Cpw, specific heat capacity of water at constant pressure. Now temperature, from what temperature? From 0 degrees centigrade to Ts degrees centigrade. It is increasing. So that is Ts plus 273 minus 0 plus 273. And what remains? Simply M will be 1 Cp Ts, and you remember this Ts will be in boiling point, not in Kelvin, because this 273 is cancelled. This is Ts is actually change in temperature. Okay, this is for water, and this value is what? What is this value? This is simply HF that is available in the steam table, that we call sensible heat, because up to the boiling point, and this is HF. Okay, what is HF? The sensible heat. We can calculate, if we do not have steam table, we can calculate how Cp into Ts. You can see Cp is generally 2.4 or something like that into Ts. Ts is say 80 degrees centigrade. Okay, 2.4 into 80. So that directly we can calculate HF this way also. That is sensible heat. That is also called enthalpy of saturated water. Sensible heat is called enthalpy of saturated water. Now, enthalpy of dry steam, we discussed. This is only we are revising the things what we have discussed earlier. Dry steam H is equal to HF, sensible heat, plus latent heat, that is equal to Hg. Wet steam, if the steam is wet and it has a dryness fraction of X, then total heat is equal to sensible heat plus heat of the dry part. What is that? X multiplied by latent heat. That is for the total heat for wet steam. Now for superheated steam, what we got? You can see H superheated steam or Carnegie-Hove, HF plus HFG plus the rest. After dry steam, how much heat is added? mCpg T sup minus this. This will be always 1, okay, for per unit mass. Cpg is what? Specific heat of superheated steam. T sup is temperature of superheated steam. Ts is temperature of saturation temperature of steam. Ts, boiling point. Okay. So HF plus HFG is again Hg plus this much. Now you tell me, what is this? T sup minus Ts.
A degree of superheated steam.
Good, very good, excellent.
Degree of superheated.
Good. Degree of, what do you say? Degree of?
Superheated steam.
No. You should say degree of superheat. Okay? Degree of superheat. That means how much temperature beyond Ts. That is, what is the degree of heating? Degree of superheat. Okay, again you tell me, what is this? What do we call this? mCpg T sup minus Ts.
Enthalpy of superheated steam.
Sir, heat of
Sorry,
superheated
Enthalpy or heat of
superheated steam.
superheated steam. No, you say the appropriate term is heat of superheat. We say it is superheated, but how much superheated? That term is called heat of superheated. Heat of superheat. So if it is specific, definitely this M will not be there. mCpg, M will not be there means M is equal to 1. So what is total heat of superheated steam? That is equal to total heat of dry steam plus heat of superheat. TH diagram we saw. This is sensible heat, this is latent heat of vaporization, and this is the heat of superheat. This part is heat of superheat, this part is latent heat of evaporation, and this part is what? Sensible heat. Now we have also discussed specific volume per unit mass. If we represent it by Vs, then what is the specific volume of water? This is simply Vf. because volume of water does not change. Although temperature increases, the volume does not change. Very slight quantity of temperature, volume changes, but that is considered for all practical purposes. This is considered as no change in volume. That is why specific heat of water is equal to Vf. Okay. Then for dry steam, what is the specific volume? We said Vg, and we also said Vg is much greater than Vf. Now, if it is wet steam, then we will consider that volume is x into Vg, and also we can write plus 1 minus x. This is the volume of water particles suspended in the wet steam. Now, this is considered to be 0 for all practical purposes. That means it remains x into Vg. Now, if it is a superheated steam, then specific volume of superheated steam, just now we have discussed T sub divided by Ts into Vg. Now come to internal energy. This we have discussed today only. So what is internal energy? We have discussed. This comes from this equation. Okay, enthalpy is equal to internal energy plus PV, and V is Vg because we are talking about steam. Now, if the steam is wet, then internal energy W, enthalpy of wet steam minus work done. Work done is, it is wet steam, that is why we have to multiply by x, the dryness fraction of steam. X is what? dF, dryness fraction of steam. And if the steam is dry, then internal energy of dry steam is equal to Hg, enthalpy of dry steam minus work done, PVG. And for superheated steam, U sub is equal to H sub minus V sub. We can find out H sub, we can find out V sub separately. What is H sub we have got? H sub just we have discussed Hg plus Cpg T sub minus Ts. Again, what is V sub? We have discussed V sub is equal to T sub divided by Ts into Vg. So from these two quantities we can calculate the internal energy of superheated steam. Entropy also today we discussed.